Welcome to my YouTube channel. Today I am going to discuss about stress and strain. Stress and strain is important to find out the strength of a material. There are different type of a material such as a steel, copper, brass, iron. Those analyses are useful. The figure is showing stress and strain curve. So before starting the analysis, I go to the basic concepts about stress and strain. For example, that is your rod. You applied a force F here, the rod with a cross-sectional area A. Then your stress, in this case, is equal to force per unit area. Units of stress, Newton per meter square, similar to the pressure unit. Stress denoted by a symbol sigma, that is a Greek word. For, for example, that is your rectangular block having length 1 meter. I applied a force. There is a deformations in the material with the applications of a this force, and material does not restore its original shape, and slight increase in the length. That increase length is zero point 0.1 meter. That increase is your change in length as compared to the original length. Now I am coming to the strain. That is also a property of a material is equal to the change in length, that is del L our original length, that is L. Strain denoted by a symbol epsilon. You can write in that way, epsilon. Strain does not have any units because that is the ratio between two similar lengths. Right. Now I coming to the curve. I relate this curve with a simple example. Right? That is my hook connected with the rod. I applying a force 10 Newton to pull this spring. 10 Newton force I applied. Sorry. So I applied 10 Newton force to pull this spring, and spring restore its original position. Deformation is not permanent. Right? So there is a linear behavior, stress and strain. If you relate that one with your curve, that portions of a curve from this point to this point is showing linear deformation. When you're removing force, spring back to its original positions. If I apply force 15 Newton, original length of a spring is, for example, 1 meter. When I remove that force, spring length becomes 10.1 meter. There is a permanent deformations in the spring. So if you relate with the strength of a material, when you apply a force on a material and material change its shape, increase or decrease in the length, so that's mean that is the deformations of a material, deformations. These regions all up to the failure point is showing deformations. The next point to the elastic regions, so that is your elastic regions. Next point to the elastic regions is your yield strength. The maximum stress on that material showing the ultimate strength of a material. Right? Now, the failure regions, if you relate the same example, increases the force and spring broke into two pieces, such as 20 Newton when you're pulling the string. So that regions is showing on the curve is failure regions. The Young modulus is also an important property. That is the slope of linear regions of a curve. For example, if that point of a curve showing x1 that relate with some number and that regions that region showing x1 and that region showing y1, and we take one more point here that's showing y2, here showing x1, this point. Okay, so if we take this slope and we know that is y1 minus y2, x1 minus x2. So that is your Young modulus. Y2 is showing the stress values and x1 minus x2 showing the strains value between 2 points. So that's give you a value of Young modulus when you have a linear behavior between stress and strain. So hopefully you enjoy these sessions and that give you a basic idea how stress, strain, and Young modulus work. Thank you watching for this video and I hope I will see you soon.